So actually we have three major space missions right now that are all funded by NASA. Lunar Ice Cube, which is a big mission, the DM processor, DM7, and then CXBN2. And they're all basically being built and designed here by faculty and staff and students at Morehead State University. CXBN2 is a follow-on to the CXBN1 mission, and it's an astrophysics mission. It's one of my favorite missions because it really it's a pure science mission. So it's a small satellite that has an X-ray detector, and what we're trying to do is measure an aspect of the physics of the early universe called the diffuse X-ray background.
I'm an undergrad here in Morehead State in space systems engineering. And well, that's my school job, right? Going to class and stuff. But also I'm working on some of the projects that we have here in Morehead, namely the CXBN2 and the Lunar Ice Cube.
Lunar Ice Cube is the coolest project we've ever done. It's about an $8.5 million program. It is a bit bigger satellite, the size of a large cereal box essentially. We call it a 6U CubeSat. A U is 10 by 10 by 10 centimeters, so this is sort of 6 of those put together. But it's essentially a space probe, and it's going to get a ride on the maiden voyage of the largest rocket ever built in the history of the world, called the SLS, the Space Launch System. It's being built up by NASA right now, and SLS is going to launch in 2018. And it's the launch vehicle that will carry astronauts back to the International Space Station, and then ultimately onto the moon and asteroids, and even ultimately to Mars, we hope. But the first time it flies, it's not going to have astronauts. It's going to have the Orion space capsule, and they're going to swing it around the moon and test out the systems. Since it's not going to have astronauts, they're going to allow as many as 13 payloads to sort of piggyback, and these payloads will get to Earth escape velocity, and they'll go to different places. Ours was selected to go to the moon, and we're going to get into an orbit around the moon and use an infrared spectrometer to map the distribution and location of water ice on the moon. So literally we'll be sending a probe built at Morehead State with partners. We're partnering with the Jet Propulsion Laboratory, with NASA Goddard Space Flight Center, has a propulsion system built by a company called Busek, great friends of ours. Software's being developed at Vermont Tech, so it's a sort of a combination of a variety of different organizations. But it gets to the moon and it looks at the distribution, trying to understand the distribution of water ice on the moon. These are all NASA supported projects. So they're all funded by NASA. In the case of Lunar Ice Cube, it's about a $8.5 million program. It's probably the largest grant that Morehead State's ever received in the history of the institution, so we're pretty happy about that. The other two are smaller scale but very interesting projects. DM7 is a couple $100,000 mission, but we get a free ride to the International Space Station where it's going to live. And CXBN2 is basically self-capitalized, but we get a ride to space through a competitive process that we won from a NASA competition. We were actually a fairly early adopter of 3D printing techniques. We've been using 3D printers for maybe 5 years or more. It's a form of additive manufacturing where you can literally design a model in virtual space, like a CAD model, and literally print it in a variety of materials. Ours uses plastic, and it helps us to save a lot of time and effort in the design process. And just to give you an example, every satellite that we build, we design it. We sort of build it 4 times. We build it in virtual space. We build a computer model. We build a CAD model of the mechanical systems. We build up the electronic systems in a variety of programs. We typically use one called Altium. So you have a computer-generated model of the electronics systems and the mechanical systems.